Up until now, we've dealt with exponents that are integer values, 2, 4, 5, 3, 1, sometimes negative values, but we haven't really dealt with fraction exponents. So I want to go over this formula right here. It's a pretty simple formula. It's just how you convert fractions in an exponent into a radical symbol like we're used to seeing. What you do is you take the top of the fraction, right here, this m, and that becomes the exponent inside a radical symbol. And you take the bottom of the fraction, in this case n, and that becomes the index of the radical. So let's go through a couple examples, just make sure we understand how this works. X to the 3 halves. Well, I see the top of the fraction is 3, and then the bottom of the fraction is 2, so that goes right here. But if you don't want to write the 2, that's fine, because the square root naturally means the second root. In this example, I'm going to turn that back into a rational exponent, and I like to start with the top of the fraction. That's 5, so that's going to go up here. And when I look to see what I divided by, that is the index over here, so that's 5/3. Now, in this example, normally we would never multiply two radicals together which have different indices. And I'll give you an example. If I had the third root of 10 times the square root of 5, you don't touch it. That is as simplified as you get there. You can't go anywhere with it. But it's different sometimes when you're dealing with radicals. And in this example that I'm looking at over here, what's different is the variable under the radical sign is the same. It's not 10 over here or 5 over there. It's just x and x. And if it's the same variable, you get to work with this with a little more flexibility than you would otherwise. So let's first turn these into rational exponents and see what we can do with that. This becomes x to the 4/7 times x to the 5 halves. Okay. Now, if you remember how exponents work in mathematical operations, you remember that when you multiply two things together, like, I'll use a simpler example, x squared times x cubed, what's that? You should say x to the 5th, right? You add up the exponents. So we're going to add up these exponents. We're going to say this is 4/7 plus 5 halves. Now, if you have any kind of fraction anxiety, it's probably hitting a peak right now. We're just going to have to get over that because we're going to be doing a lot with fractions this year. Common denominators. Remember, that's how we add fractions together. So this becomes x 4/7 times 2/2 gives you 8/14. And 5/2 times 7/7 gives you 35/14. If you want to pause the video, make sure you understand why those fraction conversions work. That's great. I'm going to keep going. 8 plus 35 is 43, and of course it's 43/14, which we can turn back into radical form like this. We say, well, that's x to the 43rd power. It's kind of big. And the 14th root of that. Okay, so there's not a whole lot of practical use in this particular exercise, but it's a useful way to basically assess whether you guys understand the concept of these rational exponents here. Make sure you understand how those really work. The usefulness of rational exponents actually comes up later when we get into some of the messier equations, and we'll see that later on in this class.